Hi, this is Srija. I'm from CSDC section department. Today I'm discussing about the topic form factor and peak factor of AC voltage or AC current. Now we'll enter into our slides to know more about form factor and peak factor. The form factor of an alternating current waveform is the ratio of the RMS value to the average value. The peak factor is the peak amplitude of the waveform divided by the RMS value of the waveform. Now, form factor. We know about form factor definition. The definition is the ratio of the root mean square value to the average value of an alternating current quantity, that is current or voltage, is called form factor. The average of all the instantaneous values of current and voltage over one complete cycle is known as the average value of the alternating quantities. Now, form factor is equals to IRMS by I average or ERMS by E average. Mathematically, it is expressed as IRMS and ERMS are the roots mean square values of the current and the voltage respectively, and I average and E average are the average values of the alternating current and the voltage respectively. For the current varying sinusoidally, the form factor is given as form factor is equals to IRMS by I average is equals to Im by root 2 by 2Im by pi is equals to pi Im by 2 root 2 Im is equals to 1.11. So the value of form factor is 1.11. There is a relation between the peak value, the average value, and the root mean square, that is average RMS value of an alternating quantity. Therefore, to express the relationship between all those three quantities, the two factors are used, namely as peak factor and form factor. The form factor for the various sinusoidal waveforms are as follows. For a sine wave, it is pi by 2 root 2 is equals to 1.11072073. For a half wave rectified sine wave, it is pi by 2 is equals to 1.5707963. And for a full wave rectified sine wave, it is pi by 2 root 2 is equals to 1.11072073. For a square wave, it is equal to 1. For triangular waveform, it is 2 by root 3 is equals to 1.15470054. For sawtooth waveform, it is 2 by root 3 is equals to 1.15470054. This is all about the form factor. I hope with these two slides you something understood about the form factor. We enter into our next slides. Now we have completed about some information about form factor. Now we are discussing about peak factor. Definition: peak factor is defined as the ratio of maximum value to the RMS value of an alternating quantity. The alternating quantities can be voltage or current. The maximum value is the peak value or the crest value or the amplitude of the voltage or current. The root mean square value is the amount of heat produced by the alternating current will be same when the direct supply of current is passed through the same resistance in the same given time. Mathematically, it is expressed as peak factor is equals to Im by IRMS or Em by ERMS. Where Im and Em are the maximum value of the current and the voltage respectively, and IRMS and ERMS are the roots mean square value of the alternating current and the voltage respectively. For the current varying sinusoidally, the peak factor is given as peak factor is equals to Im by IRMS is equals to Im by root 2 is equals to root 2. The root 2 value is 1.4142. So the value of peak factor is also 1.4142. Now we have a table here uh, containing four values. Uh, Table contains waveform, shape, maximum value, average value, RMS value, form factor, and crest factor. And the waveforms are we have sinusoidal wave, square wave, triangular wave, half wave, rectified wave. We have four types of waves. Sinusoidal wave shape was like this as appearing in this slide, and the maximum value is am, and the average value is 24 m by pi, and the RMS value is am by root 2, and the form factor value is am by root 2 by 24 20, 22 am by pi is equals to 1.11, and the crest factor is am by root 2 is equals to we are get cancelled of am and we are getting the last answer is root 2. Now we are discussing about square wave. This square wave was like the shape was like also square. It containing minus m2 plus m minus am2 plus am, and the maximum value is am, and the average value is also am, and the RMS value is also am, and the form factor value is am by am is equals to we get cancel of am and am will get 1, and the crest factor is also am by am is equals to 1. Now the next waveform is triangular waveform. The triangular waveform is the maximum values uh, as we see in this table. The waveform is also like a triangle. Its maximum value is am, and the average value is am by 2, because we are getting downside of the triangle, half triangle, and the RMS value is am by root 3, and the form factor is am by root 3 by am by 2, where am was get cancelled and we are getting 2 by root 3, and the crest factor is am by root 3. We cancelled am and am, we are getting the answer as root 3. And next we have half wave rectified wave. In this we half wave rectified wave shape was like this, and the maximum value is am, and the average value is am by pi, and the RMS value is am by 2, and the form factor is am by 2 am by pi. We are cancelling am, and we are getting pi by 2, and the crest factor is 2. I hope you understood about this table. We get into our next slide. Now, what is the form factor of AC voltage? The form factor of an AC waveform is the ratio of its RMS value divided by its average value. Square-shaped waveforms always have crest and form factors equals to 1, since the peak in is the same as the RMS and average values. Now, what is the peak factor of AC voltage? The form factor in AC is defined as the ratio of RMS value and the average value, whereas the peak factor is defined as the ratio of the RMS value And the peak value. The numerical value of peak factor of sinusoidal wave is. Now, what is peak or amplitude or crest factor? Peak factor, the ratio of maximum value to the RMS value of an alternating quantity, is known as peak factor. That is, peak factor is equals to maximum value by RMS value. The value of peak factor also depends upon the waveform of the alternating quantity. For an alternating voltage or current varying sinusoidally, its value is 1.414, that is for a sinusoidal voltage or current. Now peak factor is equals to maximum value by 0.707 into maximum value. Now, the peak factor is of much greater importance because it indicates the maximum voltage being applied to the various parts of the apparatus. For instance, when an alternating voltage is applied across a cable or capacitor, the breakdown of insulation will depend upon the maximum voltage. The insulation must be able to withstand the maximum rather than the RMS value of voltage. Note: peak factor is also called crest factor or amplitude factor. The maximum value reached by an alternating quantity in one cycle is known as the peak value. This article let us know in detail about alternating current, the RMS value of alternating current, the RMS value of the AC formula, and the RMS value of alternating current derivation. Now, before, as we discussed in the before slide, we discussed about various topics. So in this we'll discuss about those topics. What is an alternating current? Alternating current is defined as the current whose magnitude changes with the time and also reverses its direction periodically. The general equation is given. RMS value of alternating current. RMS stands for root mean square of instantaneous current values. The RMS value of alternating current is given by direct current which flows through a resistance. The RMS value of AC is greater than the average value. The RMS value of sine current wave can be determined by the area covered in half cycle. This is applicable to all the waves, which include sinusoidal, non-sinusoidal, symmetrical, and asymmetrical. It is denoted by IRMS or IV. Now, the form factor and peak factor, since the effective or voltage or the RMS voltage is XRMS is equals to 1 by R integral x into 1 dx, and the average value is then the form factor and the peak factor or crest factor. Peak factor by crest factor is equals to RMS by average. Hence, for any sinusoidal function, the AC current or voltage is Kf is equals to 1.11 and Gf is equals to 1.414. Now, fundamentals of alternating current AC circuits. We have some points here. We discuss about them. What is the need for an AC circuit? The generation of single phase voltage, the relation between time and angle, the maximum, average and effective value, the form factor and peak factor, phasor representation of sinusoidal waveform, voltage and current relationship in pure resistive, inductive and capacitive circuit at steady state, analysis of single phase AC circuit resistance, reactance and impedance, conductance, susceptance, and admittance. Now, considering the above equation, the current changes at any instantaneous time if the current is passed through the electric circuit, and it can be assumed to remain constant for any small time dt. As current is passed for a short time, a small amount of charge is flown through the circuit in time dt, and it is represented as, if the current I is indicated as a sine function, then I is equals to I naught sine omega t, dq is equals to I dt, and dq is equals to I naught sine omega t dt. And at half the period of an alternating current, the amount of charge passed through the circuit at time t by 2 is given by q is equals to t by 2 integral 0 to t by 2 I naught sine omega t dt, and q is equals to I naught integral 0 to t by 2 sine omega t dt. So for upper and lower, we are taking I naught to the outside, and q is equals to I naught sine integration is minus cos omega t by omega, interval 0 to t by 2, and q is equals to minus I naught by omega. We are removing the minus sign to the outside, and we are removing the omega also to the denominator also, to open minus I naught by omega into cos omega t, interval 0 to t by 2. Now q is equals to minus I naught t by 2 pi cos pi minus cos 0. We are substituting the t by 2 values. Q is equals to minus I naught t by 2 pi, where cos pi value is minus 1 and cos 0 value is 1. In this we have minus sign, so we are getting minus 1 minus 1. Now q is equals to I naught t by pi. It is a equation 1. So here we are having a graph. It's saying about periodic time, peak to peak value, RMS value, average value, central line may also be 0. Frequency is equals to 1 by t. So I hope you understood this graph. And next we have important terms of sinusoidal wave, theory and numerical, peak, peak value, average value, RMS value, form factor and peak factor. These are the theory and numerical important terms of sinusoidal wave. And beside of that we have a graph of sinusoidal wave. A is equals to Ax sine x plus t. Now RMS value of alternating current. RMS stands for root mean square of instantaneous current values. The RMS value of alternating current is given by direct current which flows through a resistance. The RMS value of AC is greater than the average value. The RMS value of sine current wave can be determined by the area covered in half cycle. This is applicable to all the waves, which include sinusoidal, non-sinusoidal, symmetrical, and asymmetrical. It is denoted by IRMS or IV. So, with this, I end this session. I hope you all understood and you like this video. Thank you.